In this video, we are going to practice solving polynomial equations. In particular, the skills that we are going to go over in this video will be helpful for solving polynomial equations of degree 3 or higher. So we're going to do this problem, number 64. All right, the basic idea behind this problem is this. We are going to test different numbers in hopes of finding a zero of this polynomial. Or however, we're not going to just try any random number. We are going to use what is called the Rational Zeros Theorem to narrow down our possibilities. So, first, we are going to find all of the factors of the constant term. And these are equal to, the factors of 9 are plus or minus 1, plus or minus 3, and plus or minus 9. We do the same thing for the coefficient of our leading term, or we find the lead coefficient. Now there is no number here, but obviously we could just put a 1 right there. We call this list, these numbers Q, and so we're going to find the factors of 1. But that is very short list. The only factors of 1 are plus or minus 1. From this, we will be able to find the possible rational zeros of this polynomial. We'll call this f of x. Okay? So we're going to say f of x is equal to x to the fourth minus 2x to the third plus 10x squared minus 18x plus 9. And if we can find the zeros, then we will find all the values of x for which this is equal to 0. Now, if you ever have a polynomial equation that you're trying to solve, which has numbers on both sides of the equal sign, or terms on the non-zero terms on both sides of the equal sign, just get everything to one side and you can follow these same steps. All right, so the way we do this is the rational zero theorem tells us that any rational zero of f of x will be equal to one of the possible values of p divided by one of the possible values of q. So our list in this case will be all the numbers on at the top divided by all the numbers at the bottom. But since in this case we're dividing by either plus or minus 1, we're really, when we divide out, we're going to get the same exact list as we have at the top. So the possible values of p divided by q are really plus or minus 1, divided by plus or minus 1, which is just plus or minus 1, plus or minus 3, again divided by plus or minus 1 will not change that, and plus or minus 9. Okay, so when your lead coefficient is 1, this is very easy, and you just end up using the list, the first list that you made, the factors of the constant term. All right. Now that I have my list, I am going to use synthetic division to try to decide if any of these are actual zeros of our function f of x. And I just go from the smallest number to the biggest number, alternating from positive to negative, so I'm going to start with positive 1. I'm going to write down all of my coefficients of f of x, and this is, those numbers I just wrote down come from here. Bring down my 1. 1 times 1 is 1. Negative 2 plus 1 is negative 1. 1 times negative 1 is negative 1. And then 10 minus 1 is 9. 1 times 9 is 9. And this ends up being negative 18 plus 9 is negative 9. And then 1 times negative 9 is negative 9. And when I add these together, I get 0. So I ended up getting very lucky, and I found a 0 right away. So since the remainder is 0, that means that 1 is a 0 of f of x, which means that x minus 1 is a factor of f of x. And so I can actually rewrite f of x having x minus 1 as a factor, and the remaining factor will be precisely this polynomial. Now, the original polynomial started at degree 4, so when we divide out a polynomial of degree 1, we'll be left with a polynomial of degree 3. So this would be x to the third minus x squared plus 9x minus 9. Okay? And so now I want to basically repeat this process, but I'm going to repeat this process for this remaining polynomial. I'm going to try to see, can I find a 0 of this remaining function? Because if it's a 0 of this function, it will be a 0 of the original function as well. Again, I am still going to use this list, and one thing you have to be careful of is you should make sure that you always test every number, even if you already tested it before, because it is possible that 1 is still a 0 of this polynomial. Just because it worked for the first time doesn't mean we skip it for the new polynomial, because maybe 1 is a 0 of f of x of multiplicity 2 or higher. So I'm going to start with 1. And I'm going to use synthetic division, bring down my 1. 1 times 1 is 1. Negative 1 times 1 is 0. 1 times 0 is 0. 9 plus 0 is 9. 1 times 9 is positive 9, and it's a good thing that I tested this again because this ended up working. Negative 9 plus 9 is 0. So that means that 1 is a 0, and x minus 1 is a factor. And so I'm factoring out a second x minus 1. And then what's left over will be this polynomial. And again, we started with x to the third, so this will be, that was degree 3. This new polynomial, after we factor out another x minus 1, will be degree 2, and it's just going to be x squared plus 9. Once we get to a point where there is just a quadratic polynomial left, we should, instead of doing synthetic division and testing numbers, we should use what we know about solving quadratic equations. And here is an example where we have a quadratic equation that is missing the x term. And so the best way to solve this is just to set up an equation and solve for x. And in this case, we just subtract 9 from both sides. These cancel out. We're left with x squared is equal to negative 9. Take the square root of both sides. Now, as you can see, this ends up being we end up with a negative square root, which means that this is not a real number. It is a complex number. In fact, if we simplified it, this would be equal to plus or minus 3i. However, if you look at the instructions, in this case, it says to solve each equation in the real number system. So since this is not a real solution, we aren't going to count that. Okay? So our solution set for our equation is just one number 1. In other words, the only solution is x equals 1. That is the only real number that can solve that equation. All right, I hope that was helpful, and we will see you in the next video.